meet 37 blow counts per foot after being driven as far as possible, another pile must be spliced atop the pile and driven to blow count. This process will take 2 to 3 hours to complete. Once the 4 piles are driven to blow count, the ramp will be lifted by the crawler crane to achieve the required 7.5-degree slope, and the piles will be gripped to the spud well. Excess pile will be cut off as necessary to no more than 3 feet above the roadway to allow the ratch to safely transit down the roadway. The second beach ramp section will be cantilevered 1 pontoon at a time, and 2 external angled spud wells will be installed. Once positioned, 2 38 or 57-foot piles, depending on bottom conditions, will be stabbed through the spud wells and the piles driven. The end of the second ramp section will be lifted by the crane so it aligns with the first section, and the grippers will be tightened. The roadway installation begins immediately following the completion of the beach ramp. When installing the first roadway section, pontoons are cantilevered 1 at a time off the ends of previously installed pontoons. The ratch transports 3 P40G pontoons and 4 piles from the staging areas to the work face. Additionally, a forklift will deliver 4 external spud wells with grippers to the work face. The pontoons for the first roadway section are staged concurrent with installation of the second beach ramp section. The first roadway section is installed using angled connectors used to connect the first roadway section to the second beach ramp section. The angled connectors allow for horizontal alignment of the roadway with the 7.5-degree angle of the ramp. The standard roadway construction is 1 pontoon at a time. Procedures for staging and installing the second and all subsequent roadway sections are similar to those for the first roadway section, with the exception of the types of connectors and number of spud wells and piles used. The second and all subsequent roadway sections are comprised of 3 P40G pontoons, 2 standard external spud wells, and 2 piles up to 76 feet, depending on depth and bottom conditions. The process used to install the pier head is similar to the roadway process, except that internal spud wells incorporated into the P40S pontoons are used instead of external spud wells. As with the roadway, pontoons are connected to and cantilevered from the seaward connector slots of previously installed sections. After piles have been driven in the appropriate spud wells, the sections are lifted to grade level, gripped to the piles, and the piles cut at least 2 inches below the deck of the roadway so pile covers can fit flush to the deck. The pile covers are installed immediately to prevent personnel or equipment from falling into the pile. The pier head is 9 pontoons wide by 6 pontoons long, 72 feet by 240 feet. The pier head is comprised of 54 pontoons of various types, including 24 spudwell pontoons and 35 piles of various lengths, depending on depth and bottom conditions. The completed pier head includes installation of all pontoons, pier head piles, and other related items. There are 17 steps that must be followed by the pier head crew and crane operators to outfit and install the pontoons, stab and drive pile, raise sections to grade level, apply grippers, cut pile, and install pile covers to complete installation of the pier head. The ELCAS has a fender system that extends the total length of the pier head on both sides. A 1-wide pontoon fender section floats in the water on both sides of the elevated pier head to allow lighterage to safely moor. The fender system is made of 2 strings of 6 P40F pontoons, 1 for each side of the pier head, and 16 piles of various lengths depending on depth and bottom conditions. The fender system is complete with fender cushions, rigging, lifelines, and mooring cleats. The fender strings are designed to provide suitable mooring locations for lighterage during cargo throughput operations. Each fender string is held in position by piles driven through the internal spud wells of the fender pontoons. The fender piles are supported at the top by fender pile top braces. The fender pile top braces are attached to pierhead pontoons. The fender pile top braces remain in place to support the pile after the fender pontoon is lowered into the water by the crawler crane. Each top brace is fitted with mounting points for the installation of safety lines. The ELCAS is equipped with two 56-foot air motor-driven turntable assemblies for rotating cargo vehicles 180 degrees in order to minimize pierhead area. The crawler crane is used to mount the turntable on the pierhead. The turntable assemblies are capable of supporting a laden tractor trailer weighing up to 65 tons. Each turntable is made up of a runway assembly, a center pivot base assembly, a ramp assembly, and a control console. The ELCAS has a lighting system that consists of a series of floodlights to illuminate the marshalling yard, ramp area, roadway, and pierhead. Additionally, two floodlight trailers are provided that can be used as temporary lights or emergency lights. The lighting system uses two generators producing AC power for all the lights. Portable 12-volt battery-powered navigational lights are installed on the roadway and pierhead to prevent lighterage from colliding with the pier. Disassembly and retrieval of the pierhead, roadway, and beach ramp entails the use of cranes, forklifts, ratchets, and the pile extractor for removal of the pier system. The pile extractor uses the vibratory energy and line pull of the 200-ton crane to loosen the ground around the pile to remove it. Pierhead retrieval is accomplished in a similar manner to the construction effort and occurs essentially in reverse order of assembly. When ELCAS operations are ending, equipment will be returned, disassembled, and repacked in the original containers in preparation for backloading onto the pontoon barges. As the ELCAS is disassembled and pontoons are returned to the beach, the 5-wide pontoon barges will be reassembled and end connected to a warping tug or power module. The pontoon barges will then be loaded in the reverse order of offloading, and the equipment will be returned to the crane ship for backloading. After the last pontoon barge load is returned to the ship, the barges will be disassembled alongside the crane ship and the pontoons, warping tug, and power module backloaded onto the ship. The elevated causeway is an expeditionary pier facility that can be transported into a theater of operations to provide logistic support to our joint expeditionary forces. The ELCAS is a temporary pier facility made from connected ISO-compatible 40-foot steel pontoons elevated on piles extending seaward across the surf zone up to 3,000 feet from the beach. The ELCAS provides throughput of containerized cargo offloaded from lighterage at the pierhead and transported by trucks to the beach. Amphibious Construction Battalion personnel are assigned to support the elevated causeway. Personnel consisting of an officer in charge, assistant officer in charge, plus 76 additional crew members are required in 2 shifts to install, operate, maintain, and retrieve the elevated causeway. Correct performance of each step in the assembly process is important for timely construction and smooth operation of the ELCAS. The elevated causeway is essential to our nation's military needs and provides a critical system to offload cargo in an expeditionary and austere environment. ELCAS greatly assists in fighting and winning our nation's wars and fulfills the needs of our combatant commanders and their units in the field.